Alright, good morning everybody. We're continuing 6.2 sum and difference formulas. Basically we have three formulas: sine, cosine and tangent, for sine, cosine and tangent functions, and we already saw a couple about sine and cosine, I think, and we were about to start this one, right? We haven't finished this one yet. Alright, why don't we take a look at this? It says find the exact value. So trying to punch in these numbers into calculator and computing tangent inverse and cosine inverse is not gonna work. You're gonna get an approximate answer. It's not going to be valid. So what we need to do here is apply one of the convenient formulas on the right side and figure out this thing. But what we know inverse functions does, do you remember them from 5.7, the last section in chapter 5? Basically, an inverse function turns a number into an angle. So this is going to be an angle. But what is the relation between angle and this 5/12? When you take the tangent of that angle you're supposed to find, you need to get 5/12. Okay? So what I mean here is there is an angle here in radians. There is another angle, let's call it beta. This is another angle here when you're going to compute cosine inverse. We can't exactly know how much it is. But when you look at the structure of the question, what I see here is a cosine of an angle minus another angle. So isn't this just look like this situation? Cosine of an angle minus another angle. So I will take this one all clean and call this is actually what you have in the formula U, and this is V. So you are going to expand this out by cosine U minus V formula, but rather than using the letters U and V, everywhere you need to submit tangent inverse and cosine inverse for U and V respectively. Okay? So why don't you take a lead for 1 minute and try what you get, see what you get, okay? So I want you to write down the next step on your own. Alright, let's continue this, and we have the formula says you take cos and cos of both angles first. So I have cos of this thing from the top, that's 10 inverse 5/12, and I have cos of the second, which is cos inverse 3/5, minus, plus, I observe plus here, sine of something, sine of another thing, which are 10 inverse 5/12 and cos inverse 3/5. Okay? Now, we know what happens if cosine and cosine inverse comes together, right? What happens? Cosine of cosine inverse is? Anyone? So I'm asking this part. I'm starting with the easy parts. Okay, this is easy, and the rest is not so easy, but you can get this in quickly. What is this? There is an angle whose cosine is 3/5, and you're putting it in cosine again. What will be the result? Nobody knows? What's that? Yeah, it's just 3/5. So these two cancel each other and becomes 3/5. As long as this 3/5 is between the limits -1 and 1. Because if this is 2, for example, there is no angle making cosine 2, so it could be undefined. If the number is within the allowed range, always cosine and cosine inverse cancels each other. So that was from 5.7 inverse of trig functions. So we already know this part. How do we get cosine of tan inverse 512? Okay, for this, for combinations of trig functions with other inverse trig functions, use the right triangle all the time. First off, what we have here is a theta value, right? Tangent inverse always going to give us an angle, theta, or u, you can call it if you wish. U or theta, I will call as theta. What I know about theta is its tangent is 5 over 12. When I take tangent of this theta is 5 over 12, but tangent is opposite over adjacent. So this side is 5, this side is 12. Okay? And what I need to compute is here cosine theta. Now what is cosine theta? Cosine theta is adjacent over hypotenuse. And adjacent over hypotenuse is, what is hypotenuse here? We don't know, but can you get that question mark? Hypotenuse square is square of the legs added up, right? And I believe you're gonna get this hypotenuse here 13, because this is 144, add 25 more, 169, take square root of 169, this side is 13. So cosine theta is 12 over 13. Alright, you have 3/5 everywhere. So that will be multiplied by 3/5. Now let's take a look at this one. Again, this is theta. This is theta. Same theta. If you call this theta, you need to call this theta as well. Or you can call this u if you wish, as we said earlier. But this time we are computing sine theta. What is sine theta? This is again sine theta. But sine theta is opposite over hypotenuse. And opposite over hypotenuse is 5 over 13. Alright, the last one. Alright, watch out for mistakes I'm gonna make. I call this again theta. And this is just sine of theta. Oh, we already know sine of theta is opposite over hypotenuse. So it's also 5 over 13. That's my claim. Is that right? No. You see, the sides 3/5 changed. You can no longer use the same triangle. This is not theta. Who says these two are equal? When you call these both theta, you're claiming that cotangent inverse and cosine inverse are the same. But we don't know that. So you can't call it theta first. You need to call something else, V or any other letter you wish, but I want to call it beta. And you need to make its own triangle with its own sides for beta. Okay? You can't use the old one. It's not theta, it's not this. It's beta, call. And cosine beta is 3/5. So there is an angle beta whose cosine is 3/5. Cosine means adjacent side over hypotenuse. All I need is this side. Next time the question mark squared is 25 squared minus, again, question mark squared plus 3 squared is 5 squared. So question mark squared is 25, take away 9. Question mark is 16, square root of 16, 4. So opposite side is 4, hypotenuse is 5, and we are almost done. Alright, let's multiply this out. This is 36 over 65. and this is 20 over 65. The total is 56 over 65. Do you get it? So this was a good example. It combined two subjects, inverse check functions and also recent formulas, addition of cosine u plus v. All right. Now finally we are starting the tangent formula. So I covered the sine and cosine. You only need the formulas for tangent here. Somebody is wondering what tangent minus 195 is. I have no clue. It's not on the ring of values, right? Minus 195 is, so you rotate this 195. This is your angle. Negative means it's clockwise. This is 180. 195 is somewhere here. So this is negative 195. I have no clue what the tangent value of this. Tangent is sine over cosine, y over x. I wish I had these values on the ring. I don't. I have 150, I have 180, I have 135, 120, but not 195. So I believe you're gonna make this sum or difference of two values. First off, we don't like negative angles. Is there a way to turn this into positive angle? I don't like it. For example, what is the period of tangent? It starts repeating the same value after how far? Is it 2 pi? What was the period of tangent? Madison, what was it? Pi. So can I add a pi to it, or 180? So it's gonna be still the same. This thing is gonna be still the same if you add 180 to do it. This is better. I like small, still negative, but at least this time is small. So you're computing here tangent minus 15. So they wanted to distract you with the big angle, but you know the cure. If it's too big negative, add a pi to it. It's gonna be a small negative. Now, can you compute this as sum of two different angles or difference of two different angles that you can compute each u and v? What two angles make minus 15 when you add or subtract? Anyone? Come on. Come on. Give me two angles that you can find its table values whose addition or subtraction must be minus 15.
30 minus 45.
Thank you. 30 and 45, right? So we are gonna minus, we're gonna use the difference. Or these formulas are all, we like working with radians. I like to use radian. I mean, it's okay if you use degrees, it still works with, but it looks unprofessional. Degrees is not preferable when you're doing math, especially in calculus, when you're differentiating, for example. But 30 is, it's easy to change these pi over 4. And I'm going to use this formula, which is tangent of the first minus tangent of the second. Look, first minus second, 1 plus first times second. Now it's gonna pay off. If you know these values on top of your head, it's gonna pay off right now. You can quickly finish this. Or if you don't know tangent values very well, you need to change them into sine and cosine. Sine 30 over cosine 30, for example. Do you know tangent pi over 6 on top of your head? Tangent pi over 6. What's that? Should be root 3 over 3, right? No? Is that so? Root 3 over 3? Cosine is 1 over 2. Cosine is root 3 over 2. It's 1 over root 3. I multiply both sides by root 3. It's root 3 over 3. Tangent 45 is 1. And you just use these values again. Root 3 over 3 and 1. All you need to do is set the common denominators between these two. And this becomes root 3 minus 3 over 3. The bottom becomes 3 plus root 3 over 3. Again, how did I do that? I just set the common denominator like this. This is denominator 1. By the way, you can drop this. 1 times anything is that thing. And I multiply both sides by 3. That's how I got the denominator 3. And the top is 3 plus root 3. And same deal here. I multiplied both sides by 3. Root 3 minus 3 over 3. Alright, and this is convenient. You can cancel these two. They have the same denominator. Oh, I can cancel one more thing. Actually, 2 more things. So I get all disappeared 1. Right? No, we can't. You cannot cancel any of these guys. Why? Because the operation among them is not multiplication. It's addition or subtraction, which is no pass for cancellations. You cannot cancel these because they are adding other terms or subtracting other terms. So this is your final result then. Alright. Do they? Oh, I hate this. They do. If you enter this value, it's gonna say incorrect. Because in math we can't get a radical in the denominator. Radicals in the denominator must be cured. So how do you cure such a thing? If it was only this, so I want to take the easy case. This is the easy case. If it was only one radical, nothing but a radical, how would you fix this? Root 3? Just multiply both sides by root 3. And that would cure it. But this is not simply one radical. It's added to another thing. Do you know how to fix this? Anyone? How? I believe we are gonna multiply with, yeah, Chris?
Multiply the bottom by the conjugate.
Perfect. We are gonna multiply bottom by conjugate of this thing. That means just flip the sign in the middle, but not only bottom but also the top. Top needs 1 as well. This is a plus b, a minus b formula, square difference formula, a plus b, a minus b. So you just need to square each term and take their difference, because a plus b times a minus b is just a square minus b square. That's one common formula, right? And the top needs to be, unfortunately, foiled. There is no shortcut for this part. It's not a minus b, a plus b thing. So we need to multiply first outside, inside last terms, which is root 3 first terms. Outside terms is just 3. Inside terms is just minus 9. And last terms is plus 3 root 3. That makes twice these guys. There is a double. So 6 root 3. And these are like minus 12. And the bottom is 9 minus 3. 9 minus 3. Oh, this is 6. And I can split this 6 into two denominators, each underneath each piece. So it's 6 root 3 over 6 minus 12 over 6. They cancel, and we have a much better answer. Alright, this was kind of a review of basic algebra with radicals. But if it's been a while and haven't seen it, now you're seeing it, okay? Wow, such a simple looking question took a while, huh? Now we're fixed, okay. Any questions? Alright, going forward, wow, what a mess. It looks like such a mess, but if you're familiar with the formula, what you see here is tangent u plus tangent v, 1 minus u v. Oh my god, somebody just copied this formula and put it here. So this is a 3-second question. Now I like maybe 30 seconds. All you need to do is discover what u and v are and plug them in here. This is tangent u plus v formula, right? It's that thing. Tangent u plus tangent v, 1 minus tangent u tangent v. U is, what is u? 10 of what? 10 pi over 9? V is pi over 18, right? So we set the common denominators first and get total under the over the denominator 21 pi over 18. Good news, there are some common factors you can divide each number with. What is that common factor? 3, right? You can divide by 3. 7 pi over 6. What's the reference angle for 7 pi over 6? If you change this into radian, 210. So this guy has a reference angle of 30, but this is in quadrant 3. In quadrant 3, tangent is positive, so it's equal to tangent pi over 6. I'm doing reference angle work here. So ref angle is
Oh,
21 total. Yes, right? 2 times 10, 20. I added 121. Common denominator 18. Okay? Good. Because I sometimes make mistakes, so it's okay. What's tangent 30? Same thing we did earlier. Good, 3 over 3. Okay. Well, could you have get the same answer with a calculator? I doubt it. This is not a whole number. I mean, this is not, yeah. Well, not number. Pi over 18, we can't find it. So these will be approximate answers all. But your calculus can change your decimals to radicals, maybe sophisticated calculus, but we need the algebra. You see, it's so convenient now. Root 3 over 3 it is. All right. Okay, in the next question, we are going to prove an identity. We are back to proving identity. When you see the word verify the identity, what's your first step? Well, they have given an equality. You need to verify that this is a question mark. You need to verify it. So we first pick a what? Pick a what? Side. Yes. Left or right? Which side you can pick? Yeah. Which side has the potential? Left side. So we start with left hand side. Why do I pick? Because in the left side I have addition of two angles and I can do cosine u plus v. u v. And I can compute each and reduce probably. So I start with the left side, do that addition formula, which is cos minus sin. Or what? First, second. First, second. Agree? And there are there are 4 items to identify here. Only you can find out the 2. Which 2?
Cosine pi over 2.
Right. What is cosine pi over 2, guys? It's 0. How about sine pi over 2? 1. Oh, look what happened. What is 0 times cosine x? This entire thing drops out. And on the right side, minus 1 times sine x is minus sine x, which is the right hand side. The question is over. Correct? Are they asking step-by-step work here? Yeah. They have even given you the first step. What is this identity called? This is called, they just want you to name it. Combine fractions over LCD and distribute odd even property. No, this is sum and difference formula. We need to evaluate each. This is the first one was 0, the second one 1. But again, don't go with the connect math. First do it on paper, then go fill in the blanks, okay? And get minus, because it's so easy with connect math. It's kinda shortcut, but you need to be able to do this on your own first. Alright, let's take a look at the final question. Again, verify identity. You need to pick a side. Which side would you guys go with? Which side has potential? Alright, I'll give you a couple minutes to do this on your own. Okay. Alright, ready? So which side you pick? Of course the left, the one side, the side with the pluses and minuses happens on the left. Left hand side is what we start with. Sin x plus y. And then sin x minus y. So which formulas are we gonna use here? Yep, sine formulas, the top and bottom. So you just copy this and that with x and y's instead of u and v's. So it is sine x cos y plus cos x sine y, the first. Second, sine x cos y minus cos x sine y, right? So, alright, what's going on here? Yeah, these two are matched with opposite signs. They are a match with an opposite sign, so they cancel. So do we cancel these two? No, they are the same pair but same sign, so you have twice of them. So the mission accomplished. Alright, maybe you're not aware, but you've actually proven a well-known identity, which we are gonna take a look in the next section. You have just proven this. No, not in here, sorry, it's in 6.4. In 6.4, this is called product formulas. This is called a sine cosine product formula, section 6.4. We will put it in our trig identity list, just like one of these. Okay? Alright, that was it. That's 6.2. Any questions? Alright, continuing on. So, by the way, I forgot to add it to Carmen, but alright, we first start with double angle formulas, and the other half involves power reducing, or also known as half angle formulas. So they are kind of the same thing, these two. Power reducing and half angle formulas. Alright, so what is double angle formulas? Where do they come from? You have, look, you have twice an angle. Isn't this double? Double of an angle. How would you compute double of an angle? You separate it as theta and theta and apply sine u plus v formula. This is from section 6.2. You have learned this formula. If you have addition of two angles, you just write sine and cosine of them and add them, multiply and add. But these two are the same, so you have twice sine cosine, twice, and you get this formula. Sine double of an angle is twice sine single angle cosine single. Again, sine double is twice sine single cosine single. Make sense? How about cosine double? You do cosine u plus v formula, cos theta, sine theta, but this is same thing twice multiplied itself, cosine square. Same thing multiplied itself, sine square, with a difference. So cosine double is cosine single squared, sine single squared, and a difference. Alright, I wonder how they got. So this is version 1. You can use this, but sometimes it's more convenient to use version 2. I wonder how they come up with this formula. Any idea how they arrived to second formula from the first one? So we already proven this. I'm just curious how they wrote the second one, 1 minus 2 sine squared theta. How do you come from here to there? Yeah. Sine squared theta plus cosine squared theta is 1, right? Now, take this guy, no, not the other one, to this side. So cosine squared theta is 1 minus sine squared theta. And instead of this cosine squared, now you have 1 minus sine squared. Oh my god, these are the same. Same thing twice, subtracted from 1 means 1 minus twice sine squared theta. Okay? If you do this with cosine square, if you flip cosine square and replace sine square with that, you will obtain 2 cosine squared theta minus 1, the third version. Version 3, 2 cosine square minus 1 is obtained if you replace sine square by 1 minus cosine square. Okay? Replace this by 1 minus cosine square. And this minus is going to make this plus. So this cosine square minus 1 plus cosine square. So it's twice cosine square minus 1. So there are 3 options for cosine double angle. single option for sine double angle. You can pick anything you wish according to the question here involved. Okay. For tangent, there is one option, 2 tan 1 minus tan square. And here is how they obtain it. Again, they used some formula for tangent. Right? They replaced by the theta here and got this thing. Because these are matching, same thing. You have twice of them. And this is the same, multiplying, so tangent square. Okay? So we add 3 more, actually 5 more. 1, 2, 3 on this side, 2 more here, 5 more formulas, identities to the list. These are called double angle formula because what it does is relates a double of an angle into singles. Alright. And the next question is kind of long because it has 3 parts. We are gonna keep using double angle formulas we just constructed above. Sine 2t, cosine 2t, and tangent 2t to be found. But what we are given is cosine t. Okay? Cosine t is given. How do you find sine 2t first? Sine 2t is, just write the formula first. Look, first compare. This is a single, this is a double. So that's how I know I must be using double angle formula because single one is given, I need the double. Alright? Well, in the double angle formula, I need to know 2 things. I need to know what sine t is and what cosine t is as well. So this is given. They didn't give me sine t. And I'm stuck. I need to know sine t to get sine 2t. How can I get sine t? Any help?
Didn't you just make like a triangle and find that extra side?
Yes, you can do that. If you know cosine t, if this is t, cosine is adjacent over hypotenuse, you can get sine t by finding the third angle. Works. Or, this is one option. Other option is, they are kind of similar. You can use this relation between sine and cosine. Now this is called Pythagorean identity. We know cosine t, right? 4 over 7. So it's square of that. And sine t will be 1 minus, take this off from 1, 16 over 49. Next thing is 49 over 49, right? This 1 over 1 you multiply by 49. 49 over 49 minus 16 is 33 over 49. Squared. So sine t is square root of 33 over 49. Am I right? Or root 33 over 7, because I can take out 49 as 7. And we are all set. If you do the same thing with the triangle, you will get it, right? Cosine is adjacent is 4. Ignore the minus sign. Hypotenuse is 7. And you're going to get root 33 on this side. And sine is root 33 over 7. Look, root 33 over 7. Alright, there is a mistake here. Nobody caught yet. If you multiply this all out, I get minus 8 root 33 over 49, right? These two make 49. 4 and minus 4 makes minus 8 root 33. This is, I believe, incorrect. I don't have to check it, but I believe it's incorrect. Where is my mistake? I verified sine t in two ways. Ashley's way, right triangle. I did Pythagorean identity. I got the same result. There shouldn't be a mistake, right? But there is one. Yeah. Just because you build a triangle doesn't mean the answer is always positive. Triangle uses only positive sides. Length is always positive, but when you take a look at the angle, it's in quadrant 3. In quadrant 3, sine is negative. Quadrant 3 all the way when you rotate. And my mistake here was when you take square root of both sides, it's plus or minus. You need to pick the right choice. Is it plus or minus? Answer is it should be minus. The result should be plus. Okay? Eight root 33 over, what was it, 49. Good. Now we are going to cosine 2t. Now for cosine 2t, you guys have plenty of options. You can use this, that, or the last one. But only one of them makes best sense. Which one? According to what's given. Let's say you didn't do part A. Let's say you didn't do this one. You don't know sine t yet. We found it. I know we know. But let's say you don't know sine t. Which formula would you use if you don't know sine t, if the only thing you know is cosine t? It's this one, right? Pick the one that's using only cosines, not the second one, not the first one, because we don't know sine t yet. Pick the last one, 2 cosine squared minus 1. And just apply what's cosine, given cosine value here. And we will get 16 over 49, 32 over 49. Take away 49 over 49. 1 is 49 over 41, right? That's minus 17 over 49. Seems incorrect though. Is that right? Yeah. Minus 17 over 49. Good. Next, tangent 2 theta. Alright, for tangent 2 theta, you need to get tangent t's first, unfortunately. Two tangent t over 1 minus tangent t squared. Alright, to get tangent t, you need to know both sine and cosine. Well, in part A, we found sine t, which was negative root 33 over 7. And in part B, we already given cosine t. And I cancel this, it's root positive root 33 over 7. No, 4 is what tangent t is. 2 root 33 over 4, 1 minus 33 over 16. Wait a second, how did I get this? I'm squaring it. When I square root 33, it's 33. When I square 4, it's 16. And these two cancel. And this is 1 is 16 over 16. Subtract this is minus 17 over 16. Flip and multiply. I flip and multiply. Get this 8. And the result is minus 8 root 33 over 17. Am I too fast? That was 49. 17. Alright. So there wasn't any hard math tricks in number 1. It's just basically apply the formulas. Except one time we needed to use Pythagorean identity for sine, computing sine. Other than that, it was smooth sailing. I believe you shouldn't have any problems, but I need to ask again, any questions, any part you want me to repeat? Okay. Alright, yeah. It's time to do more sophisticated things. Verify the identity. That means you need to start picking one side and work out that side using what's given, what you know earlier as well. It's not just the formulas here you may need also addition, sum and difference formulas from the previous section, and maybe Pythagorean identities as well. Alright, I'll give you 2 minutes to think about this, okay? Alright, which side did you pick? Right? The right side. Okay. Right hand side. So you're leading the question now because I wasn't taking the right side.
I picked that, but not finished.
Okay. But do you think you can go anywhere with the right side? With the given formulas? No, because it's kinda the formulas is to relate double angle into singles. These are already single. And I mean I can't go back from this side to here. Yeah.
I was just avoiding the concentrics at all times, so I'll pick the right method more.
Okay. So let's go with the left side. Okay. Now this one is already double angle, receipt y-axis, so it's screaming, oh, use this formula. Oh, by the way, why should I use double angle formulas to get rid of 2x? Because on the right side I have everything single angles. This is triple, so that's a big sign, we have to fix it. This is double angle, double. So I know I need to reduce this triple to single, double to single. I know how to reduce this double to single by simple substitution of that formula, right? question is, I don't know how to reduce triple to single. I wish they have provided here triple angle formulas. Well, we don't have it, right? So what can we do?
Can't you cancel the bond cosine with
One cosine with, oh, you mean this, okay. One cosine from this, so this drops to 2x then? Yeah, it looks like it makes sense, but no. Here is the confusion we are having. This cosine 3x does not mean it's cosine cube x. It's not. I mean, this is cos x, cos x, cos x. Okay, so you can cancel one, but cosine 3x is not that. Cosine 3x is cosine of x, x, x. It's not this. And we cannot make this cosine x, cosine x, cosine x multiplication. No. Alright? So they don't cancel, unfortunately. But think something else. To be able to... Alright, you're on the 3rd floor. This is 3rd floor of a building. To go to first floor, what do you visit first? To go to first floor. We need to go to first floor, right? Single floor. Where do you go first? With an elevator, which floor? Yeah, second. So why don't you make this first, second floor plus one more, and then separate these out first. Separate these out. How? What formula is this one? Isn't this u plus v formula? What is cosine u plus v formula? It's cosine u cosine v minus sine u sine v. Let's cheat. Oh, here. Cosine u plus v is cos u cos v sine u sine v with a minus. Look, 2x x, 2x x, 2x x. What I did, that's what I did. Right here. This is 2 sine x cos x. Alright. I'm stuck again. What is next? I have now no more 3rd floor. Your some cosine is 2nd floor here. This is single floor, second, single. Single, single. So there is an imbalance right now. 2nd floor, 1st floor. You need to reduce that 2nd floor to 1st floors as well, right? Correct? So how do you reduce this and that? Cosine 2x is, you need to pick a formula. Which one you wanna pick? Careful, make a wise choice. You have 3. Sometimes having too many choices is a bad thing. I wish there was only one so I could use it. Now which one makes our life easier? Pick one and we go forward. If it doesn't work, we always can go back and fix it. Which one? First, second, third? Random, tell one. Second. Alright, if it's wrong, it's his fault. You're staying here all Friday. Okay. So second one, 1 minus 2 sine squared theta is this guy. You're multiplying with cos x and sine. Oh, we need to change sine 2x, right? I'm glad there is only one option for that. 2 sine x cos x. And you have a sine x here. Okay? Alright. I'm going to multiply this out. See what we get there. 1 minus, no, not 1 minus anymore, sorry. 1 times cosine is cosine x. And you have minus 2 sine square x, sorry. And cos x. Oh, wait a second. These two are the same, right? Can we make a square out of them? Minus 2 sine squared x cos x and 2 sine x cos x, correct? Agree? Alright, what do you see between these two guys? What relation do you have? Aren't they the same? Can't we combine them? How many do they make when you do that? Minus 2 apples, another minus 2 apples. How many apples do you have? 4. Now I'm stuck. Oh, what's that? Good question. That's what I was gonna propose. Can I cancel one cosine, one sine from this guys, and there still will be one left over because this is double? Yeah, it's adding or subtracting an object here. We can't cancel them unless we will cancel them eventually, but we need to first split them apart. Separate this denominator into 2 parts. Now you can cancel stuff because they are separated. Look. In this ratio, this guy is alone, so they can cancel as they wish. So these canceling, and there is still one thing left over here. This is sine x. And 4 and 2 is canceling as well into 2. So 2 sine x is what's left here. Oh my god, what a coincidence. It's not a coincidence, they arrange things. Okay, how about here? Canceling? Can we cancel them? Yes, we can. And can I separate 1 over 2 and 1 over sine x minus 2 sine x, right? I just separate 1 and I pull another 1 from here and couple it with sine. What is 1 over sine? Is it a match? Yes. This is the right hand side. The question is over. Identity verified. Alright. I'm going back. Here's the whole picture. Any questions? I believe no matter which one you choose, you could... No. So you made the wisest choice. If you went with this or this is the best, this was the best. These were bad choices. I'm glad you made the right choice, okay? Because you would get cubes when you foil distributed. Okay.